Hi, my name is Victor Perez from Autodesk and welcome to this chapter of VRED QuickBites where we'll be doing cool stuff in a couple of minutes. In this chapter, we're going to be digging into HDRIs. Can you tell the difference between this video here and this video here? This is lighting, you are right. The HDRs that were used to illuminate one model and the other are completely different. The second image you saw was done using an HDRI shot on location. What do we get when we do that? We get a model that actually looks like it was placed on the spot. So we increase the realism of the scene, also the physical accuracy of the model. But how do we actually get to do an HDR of the actual scene? There's two ways to do it. One is to get a DSLR with a panorama head. The camera is going to be rotating through the nodal point of the lens, so we get no parallax effect. Then you shoot from 4 to 16 images and you patch them all together. This way you get the best quality possible, and that's ideal if you are going to be looking at the HDRI directly. In this case, we are just gonna be using the lighting of the HDRI. A low quality HDR is more than enough to be able to illuminate the model. Therefore, we're going to be going the easier route, and we are going to be using a 360-degree theta camera. But the limitation of a camera like this is that it can only shoot low dynamic range images. How do we actually get a high dynamic range image out of it? The idea we have here is you shoot different exposures. So a single image cannot contain the brightness of the sun and the darkness of a black object in the scene, for example. But if you shoot several images at different exposures, then you can combine them and combine the information into an HDR file. So starting with the Theta app, we'll connect to the camera, and once you're connected to the camera, you will have to do a couple things. For the one side, we want to set the ISO of the camera to the lowest possible, in this case 100. We don't want any extra noise on the image. Secondly, you want to raise the aperture value, and this way what you get is a sharper image. Lastly, you'll have to shoot images depending on what your scene is. There will be more or less, and we'll be shooting in a 1 f-stop interval. 1 f-stop equals double the light on the scene. So if you can see the shutter speed on the camera here, we'll be doubling it each time. And this is how the images are going to be looking. So once they are imported, you will have to click Enable HDR mode. So it's going to be merging the bracketed images into an HDR and linking the positions. Since the camera wasn't moved and it's always shooting from the same position, you don't need to actually stitch any images. Next thing you will want to do is hit exposure, and here you can optimize the actual exposure of the image. You can change the precision you use up here and then just click optimize. And the last thing you have to do is just create the panorama. In this case, we are going to be creating an HDR panorama, so disabling the blended panorama and creating an HDR panorama, and just hit create panorama here. So once you have the model done, it's going to be looking like this. So this model has captured the light from the darkest blacks here to the brightest lights. In this case, it's going to be either the lamps or the environment. Next thing you can do if you want to have the right image all the time is shoot different ones in different light conditions. So in this case, this is for the cloudy day with the lights on. We can have another one with the lights on and on a sunny day. The last thing you're going to need to do is inside of VRED, go to the material editor, add and create environment. So sphere environment here. Just click there and select your HDR, and it should be automatically applied to the model. You can see already that the lights look so much better. So the next thing you want to do is just check the rotation of the environment. So in this case, you just go to transformation, and in this case, we want the car to be facing that way. So we can set the rotation to 270 degrees. There you go, so it's facing the right direction. You might want to tweak the exposure, the reflected saturation, and so on to match it with the end device that you're using. So, thanks a lot for watching this QuickBite video, and see you in the next one.